Imagine you open the hood of a car, and instead of a finely tuned engine, there's just this jumbled mess of wires and duct tape.
Oh, I can picture that.
Yeah, that's kind of what bad code can feel like for developers.
Like a nightmare.
Exactly, a total nightmare to work with.
Makes sense.
So today we're doing a deep dive into clean code by Robert C. Martin.
Oh, the classic, right?
Yeah, it's pretty much like the gold standard for writing good software, the kind that's easy to understand and maintain.
Maintainability is so crucial, especially as a project grows.
Absolutely. And what's interesting?
What's that?
Even if you're not a programmer, even if you've never written a line of code in your life, I think there's a lot to learn from this book.
Oh, but definitely.
It's really about clarity and efficiency and just good design principles that I think anyone can appreciate.
It's fascinating how a book about software can resonate with people from all walks of life.
Right.
Clean code is just packed with principles that go way beyond just programming.
Yeah, like what?
Well, it touches on clarity, communication, efficient design. Those are all principles that could be applied to almost any field.
Absolutely. And one of the first things that really stood out to me was the emphasis on choosing good names.
Yeah, it seems so basic, but
Yeah.
the book really hammers home how critical that is.
It's true, right?
In software, a name isn't just a label, it's a communication tool.
Yeah.
A good name, well, it tells you right away what a piece of code does,
Makes sense.
why it exists and how it should be used, but a bad name can lead to all sorts of confusion,
Oh, yeah.
errors, frustration for anyone trying to work with that code.
The book had this great example. It was about a variable named HP.
Okay.
And you naturally think that stands for horsepower, right?
Yeah, something obvious like that.
But it actually represented the hypotenuse of a triangle.
Oh, wow.
Can you imagine trying to debug that code?
Oh, that would be a nightmare, yeah.
Talk about pulling your hair out.
Absolutely. That's a perfect illustration of how a bad name can just derail your understanding of code.
Cool.
Imagine if one variable can cause that much confusion. Think about a whole program filled with poorly named stuff.
It makes you realize that naming things in code is almost like this,
Art form.
yeah, it needs that precision, that clarity, even a bit of creativity.
So you need to come up with names that tell you what's going on, but you also have to remember them.
Right, exactly.
The book even makes this bold claim that picking the right name for your code is as important as naming your firstborn child.
Wow.
Sounds extreme, but it gets the point across.
It really does. So,
Clear and intention-revealing names are so important in software.
yeah, that's setting the bar pretty high for naming things, for sure.
Definitely.
It makes you appreciate all the thought that goes into crafting clean code.
For sure.
Now, even with well-written names, you might still think, okay, I need to add some comments to explain this better.
Yeah, comments can be tempting.
But clean code actually takes a pretty surprising stance on that.
Oh.
It argues that you should really use comments sparingly. Yeah, Robert C. Martin, he actually calls comments a necessary evil. He believes that good code should be self-explanatory.
So the code itself tells you what it's doing.
Exactly, so you shouldn't need all these extra explanations.
I see.
So if you find yourself relying on a ton of comments to explain what's going on, that's probably a sign that you need to go back and rewrite the code to be clearer.
Makes sense. It's like if you have to label a box that already clearly shows you what's inside,
Yeah.
it's redundant.
And if the label is wrong, it could be really misleading.
Exactly.
The code should just speak for itself.
I like that.
And then the book goes on to talk about functions, which it describes as calls them the verbs of code.
The actions.
Right, and it gets really specific about how to keep functions short, focused, and well-named.
Okay.
But isn't there a risk of ending up with too many tiny functions?
Oh, yeah. You could get lost in a sea of tiny functions.
Exactly, and then it just becomes hard to keep track of everything.
It's about balance.
Right.
The author, he emphasizes that each function should do one thing well, and its name should make that one thing super clear.
I see.
This makes them easier to understand,
Okay.
easier to test, easier to reuse, which ultimately leads to a much more manageable code base.
So it's like breaking down a complex task into smaller, more digestible steps.
Exactly. And there's this great story in the book about working with Kent Beck.
Oh, yeah, he's a legend, right.
Absolutely. And the author was just blown away because in one of Kent Beck's programs, each function was only, get this, 2 to 4 lines long.
Wow, that's amazing.
It just shows how much value there is in conciseness and clarity in clean code.
It must have been incredible to see code that elegant in action.
It was really something.
Makes you wonder how you even get to that level of conciseness, right?
It's a whole different way of thinking about code.
Exactly. It's not just about getting it to work no matter how messy it might be.
It's about craftsmanship.
Yeah.
It's about constantly striving for elegance, for clarity, for maintainability.
It's like treating code as a work of art.
Precisely, instead of just something that needs to function.
That's a great way to put it.
Now let's shift gears a bit.
Okay.
Let's talk about something called code smells.
Oh, I've heard of these.
These are like warning signs that something might need a closer look in your code.
So not necessarily errors that will crash the program, but more like indicators that something could be better.
Right, they're hints that something might be off, even if the code technically works.
I bet recognizing these code smells is a valuable skill.
Absolutely. The book even dedicates a whole chapter to these code smells, like a catalog.
Really?
It's super valuable for anyone who wants to write clean and healthy code.
Like a checklist for code hygiene.
Exactly.
So give me some examples.
So some of the most common are long methods, large classes, duplicated code, too many comments, and of course the bad naming conventions that we talked about earlier.
Okay, some of those sound familiar. What about long methods? Like how long is too long?
There isn't a strict rule, but the book suggests that a method should ideally be no longer than a dozen lines or so.
Wow, that's pretty short. I see your point about minimizing comments, but aren't there times when a well-placed comment can really help clarify a complex part of the code?
There are definitely situations where they can be helpful,
Okay.
especially with really complex algorithms,
Yeah.
or when you're documenting tricky workarounds for things outside your control.
I see.
But the key is to use them only when absolutely necessary.
Like a last resort.
Right. If the code can be made clear enough on its own, that's always the best option.
So it's not about banning comments altogether, but about being strategic.
Yeah.
Using them like footnotes in a book.
Perfect analogy. They can add context, insights, but you don't want the whole book to be footnotes.
Exactly.
It's all about striking that balance between clarity and keeping things concise.
In both the code and the comments.
Right. And finding that balance takes experience and judgment.
Definitely.
Developing an eye for clean code is a journey, not a destination.
I like that.
It's about continuously learning, refining your skills, and trusting your gut about what makes code truly clean.
It sounds like it's as much about a certain mindset as it is about specific techniques.
It absolutely is.
And it's fascinating how this whole philosophy of clean code can be applied to so much more than just software.
Absolutely. It has implications far beyond programming.
But we're just getting started. We've only scratched the surface here.
We have a lot more to uncover about clean code and how it can change the way we think about design, communication, and even problem solving in general.
Definitely a lot to explore.
Looking forward to diving deeper.
Me too. This is exciting stuff.
It is.
Okay, so we've talked about writing clean code at like a very basic level.
Yeah.
You know, like names, functions, comments, that kind of thing.
Got the building blocks.
Right. But what happens when things get a little more complex?
Well, as software systems grow, they often need to do multiple things seemingly at the same time.
Right.
And that's where concurrency comes in.
Oh, yeah. Concurrency. I've heard programmers talk about it with this, like mix of excitement and dread.
It's one of those things that's incredibly powerful,
Right.
but also really easy to get wrong.
Like, you can really mess things up if you're not careful.
Absolutely.
The book mentions that these concurrency bugs can be super sneaky.
Well, they're the worst.
Because they're not always repeatable.
Yeah, it's like trying to catch a ghost.
Exactly.
Yeah.
So can you explain a little bit more about why that is? Why are those concurrency bugs so hard to pin down?
Well, imagine you have these multiple threads of execution, like different paths the code can take,
Okay.
all weaving through your program, accessing and changing shared data.
Right.
And the timing of all these interactions can be so subtle that a bug might only show up under very specific conditions.
Oh, so like a very particular sequence of events.
Exactly. And that can be incredibly hard to reproduce.
Like you might see it once and then never again.
Exactly, making it a nightmare to debug.
So it makes sense why people have those mixed feelings about concurrency.
Powerful but dangerous.
Right. And the book really stresses that you need to make sure your non-threaded code is solid, like rock solid, before even thinking about adding concurrency.
It's the foundation of everything.
Right. You don't want to build a skyscraper on a shaky foundation.
Exactly. Get your core logic working perfectly first. Test it thoroughly. Then you can start thinking about multiple threads.
So lay the groundwork first.
Absolutely.
Now, the book talks about some specific concurrency challenges that sound kind of intimidating,
Oh yeah, there are some scary ones in there.
like deadlock, live lock, and starvation.
Those are the big ones.
Can you explain what those are, but like in a way that even I can understand, someone who's not a programmer?
Sure, let's try, let's start with deadlock.
Okay.
Imagine two cars at an intersection, both waiting for the other one to go first.
Okay.
Neither one can move, and they end up blocking everyone else.
Right?
That's basically what happens in a deadlock.
So they're stuck.
Yeah, two or more threads just get stuck, each waiting for the other to release a resource.
So nothing can happen.
Right, a complete standstill in your program.
Okay, so that's a deadlock. What about live lock? Is that similar?
Live lock is a bit more subtle.
Okay.
It's where threads are constantly reacting to each other, but in a way that prevents them from actually making any progress.
So they're busy doing something but not getting anywhere?
Exactly. It's like two people trying to pass each other in a narrow hallway, but they keep getting in each other's way,
Oh, I can picture that.
shuffling back and forth forever.
So deadlock is a standstill, and live lock is like running in place.
Yeah, that's a good way to think about it.
Okay, and what about starvation? What's that one?
Starvation happens when a thread is repeatedly denied access to a resource it needs.
So it's like it's being blocked from doing its job.
Right. Imagine a busy kitchen where one cook keeps getting pushed aside.
Oh,
They can't get to the stove. They can't get the ingredients they need.
so they can't make their dish.
Exactly. The thread is basically starved out by other threads that are hogging all the resources.
It seems like all these concurrency issues, while they're hard to understand, they could have a big impact on software.
Oh, absolutely. They can cause all sorts of problems with reliability and performance.
So how do programmers actually prevent these concurrency nightmares from happening?
There are a few different strategies,
Okay.
but they all boil down to careful design and using synchronization mechanisms effectively.
Like what kind of mechanisms?
One common technique is using locks.
Okay.
It's like putting virtual traffic signals in your code.
To control the flow.
Exactly. They ensure that only one thread can access a critical section of code at a time, so you avoid conflicts over shared data.
So it's all about creating order and predictability because concurrency can get chaotic.
It definitely can.
And I'm guessing testing concurrent code is even trickier than testing regular code
Oh yeah, that's one of the biggest challenges.
because those bugs are so unpredictable.
Exactly. They depend on the timing of events, so it's like trying to hit a moving target.
That sounds really hard.
It is. But there are specialized techniques.
Like what?
Well, one approach is stress testing,
Okay.
where you basically overload the system with tons of threads, trying to make those rare timing-dependent errors happen.
Oh, so you're trying to force the bugs to show themselves.
Exactly. It's like putting your code through a really intense obstacle course
I like that analogy.
to see if it can handle the pressure.
Okay, before we move on from concurrency, I wanted to ask about the executor framework.
Oh, yeah, that's a good one.
The book mentions it, and it sounds like a really powerful tool for managing concurrency.
It is. It's a great addition to the Java programming language.
Can you explain what it does and why it's so important?
Sure. So basically, the executor framework provides this higher-level way to work with threads.
Okay.
It takes care of a lot of the low-level details for you.
So it makes things easier for the programmer.
Exactly. Instead of managing threads directly, you submit tasks to an executor,
Okay.
and it handles the scheduling and execution of those tasks using a pool of threads.
So it's like having a dedicated team to manage all those threads.
Yeah, that's a good way to think about it.
Okay, that makes sense. So it takes some of the burden off the programmer.
Exactly. It helps you write cleaner code,
Right.
more concise code.
And hopefully more correct code.
Definitely, by abstracting away some of that complexity.
So you can focus on the bigger picture.
Right.
Okay, let's switch gears a little bit again and talk about
Exactly.
those code smells in a little more detail.
Yeah, those are always fun to talk about.
So as we mentioned earlier, those code smells are like those little hints that something might be off in your code.
They're not necessarily errors, but more like indicators that something could be improved.
Or could lead to problems later on,
Exactly. They're like warning signs that you might ignore at first.
but could turn into bigger issues if you're not careful.
Right. So what are some examples of these code smells, and why should we care about them?
Yeah, give me some more examples.
Well, one very common code smell is a long method.
We talked about those before.
We did. And as we said, methods should ideally be pretty short, maybe a dozen lines or so at most.
Okay.
Long methods often try to do too many things at once.
So they're not focused.
Exactly. And that violates the single responsibility principle.
Which is?
The idea that each piece of code should have one and only one reason to change.
Okay, so each method should have a specific job.
Right. It's like trying to cram too much into a single paragraph.
It gets hard to follow.
Exactly. And hard to maintain.
So shorter methods are usually better.
Generally, yes, they tend to lead to clearer and more manageable code.
What about large classes? How do you know if a class is too big?
Again, there's no strict rule,
Okay.
but the book suggests that a class should ideally fit on a single screen.
So if you have to scroll to see all the code.
Yeah, that's probably a sign that it's doing too much and needs to be broken down.
Okay. That's a really practical guideline.
It is. It's like saying a good chapter in a book should be so long that you lose track of what you're reading.
It seems like a lot of these code smells are about managing complexity
You got it.
and keeping things modular.
Absolutely. Another common code smell is duplicated code.
Ah, yes. The dreaded copy and paste.
It's a sure sign that you're not being DIY.
DIY.
Don't repeat yourself.
I love that acronym. It's so simple, but so important.
It is, but why is duplicated code such a bad thing?
Yeah, if it works in one place, why not just copy and paste it somewhere else?
Well, while that might seem like a quick fix, it creates a maintenance nightmare later on.
How so?
Imagine you need to change that duplicated code.
Okay.
Now you have to find every place where it was copied and make the same change in each location.
Oh, that sounds tedious.
It is. It's time-consuming, error-prone, and it increases the risk of inconsistencies in your code.
It's like having multiple copies of the same document.
Exactly.
And each one has slightly different changes.
It becomes a logistical nightmare.
Okay, so keeping your code DIY makes it easier to maintain.
It does. It makes your code base smaller, easier to understand, and less prone to errors, because there's only one source of truth for each piece of functionality.
That makes sense. And then, of course, there's the issue of too many comments.
We talked about that.
We did. And the book argues that the need for a lot of comments often means the code itself isn't clear enough.
Right. If you have to add a comment to explain what the code is doing,
Yeah.
then the code itself probably needs to be rewritten.
To be more self-explanatory.
Exactly.
So comments should be used strategically.
Right. Only when absolutely necessary.
If the code can speak for itself, that's always the best option.
Absolutely. Comments should explain the why behind the code, not the what.
The why, not the what.
Right. They can provide context
Right.
or highlight tricky parts, but they shouldn't be a crutch for bad code.
It makes you think about how you write in general, not just code.
It does. Clarity is important everywhere.
So we've talked about these code smells, but how do programmers actually put these clean code principles into practice?
Well, one of the most important tools they use is a good IDE,
IDE.
an integrated development environment.
Yeah, okay.
It's basically a supercharged text editor
Oh, okay.
with tons of features designed to help you write better code.
Can you give me some examples?
Sure. One helpful feature is syntax highlighting,
Okay.
which uses different colors to show you different parts of your code, like keywords, variables, functions.
So it's easier to read
Exactly. It makes the structure of your code much clearer.
and easier to understand.
Right. Then there's code completion.
What's that?
It predicts what you're trying to type.
Oh, like autocomplete.
Exactly. And offers suggestions as you write.
That sounds pretty handy.
It is. It saves time and helps you avoid typos.
So it's like a smart assistant for coding.
Yeah. It helps you write cleaner and more efficient code.
I like it. Are there any other features that help with clean code?
Oh, yeah. Many IDEs offer powerful refactoring tools. It's the process of improving the design and structure of your code without changing what it does.
So you're not changing the functionality, just cleaning things up.
Exactly. It's like cleaning up your house.
Okay.
You're not adding any new rooms or furniture, but you're reorganizing things to make them more efficient and pleasant to live in.
I like that analogy. So refactoring tools are like those organizers that help you declutter your code.
Yeah, that's a good way to think about it.
Can you give me an example of how you'd use a refactoring tool?
Sure, let's say you have a method that's gotten too long,
Okay.
and you want to extract part of it into a separate, more focused method.
Okay.
A good refactoring tool would let you select the code you want to extract, give the new method a name, and automatically update all the references to that code throughout your program.
Wow, that sounds pretty powerful.
It is. It can save a lot of time and effort, especially when you're working with a large code base.
And probably helps prevent errors too.
Definitely. It automates a lot of the tedious and error-prone work.
Okay, the book also mentions static analysis tools. What are those?
Those are programs that analyze your code without actually running it.
Oh, so they just look at the code itself.
Right. They're like code detectives, examining your code for potential problems.
That's cool.
They can help you find bugs, security vulnerabilities, even code smells.
So they're like an extra pair of eyes checking your work.
Exactly. They help you catch errors early on.
Can you give me an example?
Sure. Let's say you're working on a team, and each developer has their own coding style.
Okay.
A static analysis tool could be configured to enforce a common set of coding standards across the entire project.
So everyone's code looks the same.
Exactly. It ensures consistency, readability, and reduces the mental effort for everyone working on the code.
So it's like a style guide for code?
Precisely. It helps promote collaboration and ensures quality.
I like it. It sounds like these tools can be really helpful for large projects.
They definitely are. And when you combine them with good coding practices,
Like writing tests.
yes, using version control and following coding standards,
Right.
you create a powerful system for producing clean, reliable, and maintainable software.
That makes sense. Speaking of coding standards, the book mentions something called Uncle Bob's formatting rules.
Ah, yes, those are classic.
I'm assuming Uncle Bob is Robert C. Martin.
It is. It's a nickname he's embraced.
He's kind of a big deal in the software world.
He is very influential, and his formatting guidelines are widely respected.
What's the point of having specific formatting rules? Isn't that just personal preference?
Well, there might be some personal preference involved,
Okay.
but consistent formatting is about much more than just how the code looks.
Oh,
It's about readability.
makes sense.
When code is formatted consistently, it's easier to scan and understand.
So you don't get bogged down in the details.
Exactly. It's like the difference between reading a well-typeset book and a handwritten note with inconsistent spacing and handwriting.
Yeah, the well-typeset book is much easier on the eyes.
Exactly. So consistent formatting makes code easier to read and maintain.
It seems like a small thing, but it can make a big difference.
It really can. It's one of those small details that pays off in the long run.
And when you combine that with meaningful names,
Right.
well-structured functions, and just the right amount of comments,
You start to see the emergence of truly clean code.
it all comes together.
It does.
And it's amazing how these principles, which started in software development, can be applied to so many other things.
Oh, absolutely. They go way beyond just writing code.
But before we explore that further, I wanted to ask about something called domain-specific languages.
Oh, DSLs. Those are interesting.
What are they, and how do they relate to clean code?
So a domain-specific language, or DSL, is a specialized language designed for a particular domain.
Okay.
They allow you to write code that's more concise and expressive.
So it's like a language tailored to a specific problem.
Exactly. It's designed to solve problems within a specific area.
Can you give me an example?
Sure. Imagine you're working on a system that handles financial transactions.
Okay.
Instead of using a general-purpose programming language, you could create a DSL specifically for defining financial rules and calculations.
So it's like a language that speaks the language of finance.
Exactly. It makes it easier to write and understand code related to that specific domain.
That sounds really powerful.
It is. DSLs are all about creating the right level of abstraction for the problem you're trying to solve.
So they can make code simpler and clearer.
Exactly, which are key principles of clean code.
And the book mentions that clean code is really important for emergent design. What's that?
Emergent design is a philosophy that embraces change
Okay.
and encourages you to take a more iterative approach to development.
So you don't plan everything out in advance.
Right, you start with a simple design and let it evolve as you learn more.
So you're constantly adapting.
Exactly, and that's where clean code becomes so crucial.
How so?
If your code is messy and hard to understand, it's really difficult to change it as your understanding of the problem evolves.
It's like trying to remodel a house that's built on a shaky foundation.
Perfect analogy. You're constantly worried that the whole thing might fall apart.
Clean code is like that solid foundation.
It lets you adapt to change gracefully, which is so important in today's world.
It's fascinating how all these concepts are connected, clean code, DSLs, emergent design.
They all support each other.
It's not just about writing code that works, it's about creating a system that can grow and change.
And that ultimately reflects a deeper understanding of the problem you're trying to solve.
That's a great way to put it. It's about more than just the technical stuff.
It is. It's about craftsmanship, clarity, and continuous improvement.
And creating something that's not only functional, but also elegant and enjoyable to work with.
Exactly. And that's what makes writing clean code so rewarding.
It's a journey, not a destination.
It is. It's about constantly learning and finding joy in the craft of creating something beautiful.
And it's inspiring to see how these principles from software development can be applied to other parts of life.
Absolutely. The principles of clean code have valuable lessons for everyone.
They can help us think about clarity, efficiency, and excellence in everything we do.
Exactly. They encourage us to strive for those qualities in all aspects of our lives.
We've covered a lot of ground in our deep dive into clean code.
We have.
From like the really specific stuff like naming and formatting.
Yeah, the nuts and bolts.
To the broader ideas of concurrency and emergent design.
Right, the big picture stuff.
And it's clear that writing clean code is about way more than just getting the software to work.
It really is.
It's almost like a whole philosophy.
Yeah, a way of thinking.
That goes beyond just the technical aspects.
Exactly. Clean code isn't just a set of rules.
Right.
It's a mindset.
Yeah.
A commitment to craftsmanship and excellence.
So I'm curious, what does that mindset actually look like in practice?
Well, one key difference is a deep sense of responsibility for the code they create.
Okay.
Clean coders take pride in their work.
Yeah.
They treat it almost like an art form.
Like a craft.
Exactly. They're not satisfied with code that just works.
Right. They want it to be good.
They're always striving for clarity,
Haha.
elegance, maintainability.
So it's a continuous process of improvement.
It is.
Always looking for ways to make the code better, even if it's already functioning correctly.
Exactly. It's about going that extra mile to make the code the best it can be.
And they pay attention to the details.
Oh, absolutely. They're meticulous about their craft.
Yeah.
They understand that even small choices,
Like what?
like the name of a variable or the indentation of a block of code,
Yeah.
those can have a big impact on the overall clarity and maintainability of the system.
It's like a sculptor paying attention to every little detail of their work,
Yes.
knowing that even the smallest imperfection can detract from the overall beauty of the piece.
That's a great way to put it.
Now, the book also talks about failing fast.
Oh, yeah. That's an important concept.
What does that mean in the context of software development?
Well, it's a philosophy that encourages you to find and fix errors as early as possible.
Okay.
Clean coders do this by writing tests that really push their code to the limits.
Because they're trying to find the breaking points.
Exactly. Try and uncover potential problems before they become big issues.
So it's about being proactive.
It is anticipating problems and catching them early.
Instead of waiting for them to blow up in your face.
Right. It seems counterintuitive.
Yeah, that does.
But by intentionally trying to break your code, you actually make it stronger in the long run.
Because you're finding the weaknesses.
Exactly. And this ties back to clean code, because clean code is much easier to test.
Okay.
When your code is well-structured and modular,
Yeah.
it's much easier to write comprehensive tests that cover all the different scenarios.
It's like having a well-organized house.
I like that analogy.
It's easier to clean and maintain because you can see right away if something is out of place.
Exactly. And you can get to it quickly.
The book also emphasizes collaboration and communication.
That's essential in software development.
Why is that so important in the context of clean code?
Well, clean code isn't just about writing code that you can understand.
Right.
It's about writing code that others can understand as well.
Because you're usually working on a team.
Exactly. Software development is a team sport.
And communication is key.
It is. It makes sure everyone's on the same page.
Working towards the same goal.
Right. So you need to think beyond your own needs and consider the perspective of others who might work with your code later on.
It's about creating a shared understanding.
Absolutely. And that often involves practices like code reviews.
Oh, yeah, where developers critique each other's work.
Exactly. They're looking for improvements and making sure everyone's following the same standards.
It's like a built-in quality control system.
It is. It helps improve the code and creates a sense of shared responsibility.
So it's not just about individual skill, it's about teamwork.
Absolutely. Clean code is a team effort.
It's really cool to see how these principles of clean code, which seem so technical at first, actually promote a more human-centered approach to software development.
It's about communication, collaboration, shared responsibility.
And that philosophy goes beyond just software.
It does. The principles of clean code can be applied to so many other areas of life.
We've talked about that throughout this deep dive.
We have.
And it's amazing how these principles can be applied to any complex task or creative endeavor.
Think about it. How can you apply them to your own work, your communication, even your daily routines?
That's a great question to think about.
How can you make things more elegant, efficient, and enjoyable?
This deep dive into clean code has given us a lot to think about.
It has.
Not just about software development,
but about the pursuit of excellence in everything we do.
It's been a pleasure exploring these ideas with you.
It's been fun.
And remember, the journey of clean code is an ongoing one.
It is.
It's about constantly striving to improve, embracing change, and finding joy in the craft of creating something beautiful and functional.
Well said.
Thank you for sharing your insights with us today.
My pleasure.
I think we can all benefit from incorporating a little bit of the clean code philosophy into our lives.
I agree.
Until next time.
See you then.